Welcome to Lesson 2, Chapter 1. We will be talking about Introduction to Sampling Techniques, Data Type, Variable, Research Methodologies, and Concepts. Learning Objectives. Define and use and identify key vocabulary terms. Name some statistical software to use. Differentiate between research methodology like experiment and observation. Differentiate between data and information. Understand quantitative and qualitative data measurements. Identify which methodology or techniques is used, in the scenarios to collect data. Define and identify, which is collecting data, sampling techniques, with examples and discussion with their advantage and disadvantage. I think both of them probably they mean the same thing, the two objectives. So I'm gonna just make a note for myself to just keep one. Define, the next topic is define and differentiate between types of variable, dependent or independent, co-founding, and extraneous. I think maybe you heard about extraneous in algebra before. And differentiates in a different scenarios. Like you have scenario, and then you need to define which one is the dependent, which one is independent, which one is a co-founding, and which one is the extraneous. Explain sampling error, non-sampling error with examples. Define the role of statistics in critical thinking and ethics problems with non-random samples. To present it by one group the next class. So this one is going to be assigned by one of you guys, like a group of 3 students. They can present it next class. Explain the use and abuse of statistics. So you can use the statistics and you can abuse statistics. To be presented by one of the group next class also. So you have 2 groups here, each group 3 students. They can work on that project and present it next class. I just need maximum 5 slides, PowerPoint slides. Can you do that or it's difficult? So one group, 3 students, only 5 slides. And just abbreviation for those two last points. So one group for this one and one group for the second one. The first group is the role of statistics and critical thinking, ethics problems with non-random samples. Another group, use and abuse of statistics, to be presented by another group. Is this clear?
Clear.
So you have to decide which group you're going to be making it. Please send me by email.
By email?
Yeah, the group and which topic you're going to use. You can decide on WhatsApp. As you know that I always put like do now activities, and you have a list of words that you're going to be using for that lesson. So here we have census, data, information, descriptive statistics, inferential statistics, experimental or observational, design experiment, population sample, quantitative data, qualitative, random sample, reliability, variable, research, dependent variable, independent variable, co-founding variable, extraneous variable, sampling errors, non-sampling errors, ethics, bias, non-response bias, measurement error, ambiguous, abuses of statistics. Those are the vocabulary for that list. Some of them were already covered. I think we covered population last time. We covered sample. We covered data. Okay. What else we covered last time? Do you remember? Some of them already covered. Vocabulary is there. So let's go for the summary. We have summary here to look. And the first summary here is variable types. We have different types of variables. We have dependent, independent, confounding, extraneous. So let's take a look at each one of them and decide on what goes with what. Okay. For example, if you have a relationship between age and height, which one you think the independent and which one is the dependent?
Age is independent and height is dependent.
Right, that's correct. The independent variable here is age, and this takes the x-axis. That's the cause. And dependent variable is the height. It's always taking the y-axis, and that's the effect. Is this clear?
Yes.
All right, let's go for more examples. In a study on how sunlight affects plants' growth. So the growth of plants was affected by what? Sun, right? So sun here is considered what? Independent, correct. The independent is the amount of sun. The more sun the plant gets, what happened? The plant height growth, right? So that's the dependent, is the plant height. Another example here is the relationship between water and plant size, number of leaves, living or dead. So which one is the independent variable here?
Water.
Water, very good. And that will be in the x-axis or the y-axis? The x-axis. That's the cause. And dependent variable is what? The size of the plants, or the number of leaves, or it's living or dead. Okay, that's the effect. Another variable is called confounding. Example, in a study on exercise and heights and weight loss, diet could be the confounding variable, diet. Okay. Another variable here is called extraneous. That is something that you ambiguously can find. For example, noise level in a classroom during a study on a test performance. That's called what? Extraneous. Can you give me another example for extraneous? I can give you another example. I can put the temperature here during your test very low. Is that going to be extraneous? Yes. Something that is you did not count it for, and it's hidden. Yeah, I can put the temperature very low so you become very cold, or I can put it very high and it's too hot. So it will affect your result on the test. So we learn how many variables now? 4 types: dependent, independent, confounding, and extraneous. Okay. Now we're going to go for data measurement data variables. We have two major types of data, and you have to remember this. One is called qualitative, but they name it as categorical. So another name for it is categorical. And then the other type is called quantitative, and they name it numerical. Okay. And in the categorical, there are 2 subcategories. One is called nominal, and the other one is ordinal. Okay. For the quantitative, we have 2 types, subtypes. One is called interval, and the other one is called ratio. Okay. I zoom in so you can be able to see it. Clear? So Now let's take a look at the qualitative data. Nominal. What is nominal? Nominal means categories without the natural order. For example, if I say, what is the eye color? Do I need an order here? I can just say black, brown, blue, green. What other colors do we have? Blue, purple. But is the order is important? No. Okay, the second type in qualitative is called ordinal. What is ordinal? Categories. Is categories means like names, right? With meaningful order. Like for example, if I'm offering a job, we can say, what is your education level? You can say high school. You can say undergraduate or graduate. Is the order here is important? Yes. Yeah, because if you have graduate, you can just choose the highest one. If you undergraduate, the second one. If you have high school, you just put high school. Also, can I give you another example? Like, for example, I have 10 horses, right? Susu, Fufu, Tutu, Momo, Kuku, okay? They are running in the race, okay? Is the order here is important when they finish up the race for the horses? Yes, we can say Fufu won the horse. He took the first place. Tutu took the second place. Susu took the third place, right? And then the fourth one and the fifth one. Okay. So now you understand the difference between nominal and ordinal. Nominal order doesn't matter. Ordinal order matters, but both of them names. Okay. Now the second type is called quantitative. Quantitative means we're dealing with numbers. So for example, there is no true zero here. For example, temperature in Celsius. Okay. What should I say about the temperature? I can say it's 45 degrees, right? I can say 44. I can say 43.
You could say minus 43.
I can say minus 43. Type ratio.
You can't be negative weight.
A true zero exists means I can say your height. What's your height? 165.5. See, the point is there. But in the temperature, you don't have to put point, just straight number. Like say, for example, if I say, how old are you? Is it going to be interval or ratio? Ratio, because I can say your age is 22.5.53. So what's 5? It's like 5 months. What is 3? 3 days or 3 weeks or 3. Okay. So interval and ratio. Ratio, you have decimal. You have continuation. That's what you call it. I don't know if I write here continuous. Yes, I wrote down here continuous. See the continuous? If I say, how many brothers and sisters do you have? Is it going to be interval or a ratio? Interval, correct. If I say how many eggs in the fridge? Interval. Okay. If I say how much is your weight? Ratio. So I think you're okay with this. If you're okay, raise your hand. So now we know measurement of data variables, okay? So let's move to the next type. Now we have something called sampling technique. When you do the research, how are you going to collect which ways, what ways, or what type of sampling techniques are you going to use, okay? So we have here many different types of sampling technique, but I took only the first 5, okay? which is called symbol, systematic, stratified, cluster, and convenience. Symbol means everybody has equal chance, and just symbol. I ask you to put your name on a piece of paper. Second student, third student, fourth, fifth, sixth, seven, 8, 9, 10, and then we put it inside this bag. Okay, everybody has equal opportunity, and then I ask somebody from outside to come here, put his hand, and choose one student. He will be the winner. So that's simple. Everybody has an equal chance of doing, participating and winning. Okay. For example, selecting 10 students randomly from a class of 50. Here I'm taking 10 students. Okay. There is an advantage for the symbol technique. What is the advantage? Minimize bias. There is no bias in this. Ensures equal chance for each individual. What is the disadvantage? Can be time consuming and impractical for large population. Let's say, for example, I want to do random winning for all BMU students. So how many BMU students? Maybe 5,000. Can I go and collect names for 5,000 on a piece of paper and then put it here, and then we choose one? It's going to be difficult. One bag is not going to be enough, right? And sometimes when you go to supermarket and they tell put the receipt or put paper inside, and you find the whole box is full, right? And then they have to bring another box and third box and fourth box. It's not convenient for supermarket to do something like this on a box, because there are thousands of participants in this. Okay, so they can do it in another way by maybe asking the customer to go to the internet and register their names, so it will be much easier. And then from there they can pick 10 winners. There is a second type, is called systematic sampling. For example, picking every fifth person from a list. I remember when I was in Canada, in Toronto, I was like taking the flight to, I was coming back to Saudi Arabia, and then this Pakistani security guard, he came to me and he said, "Give me your hands." So I said, "Okay." So I gave him my hand, and then he have a piece of cotton. He swabbed my hand like this, and then he took the cotton and he put it in the machine, and the result came negative. But then I asked him, why me? Why you selected me and not the person behind me and the person after me? He said it's systematic. Every fifth person, I have to take a test from him. Okay, so I didn't feel like this, because I felt like there is a discrimination. So there is advantage for this and disadvantage. It's easy to implement. The disadvantage may introduce bias. You see, it's written there. I felt like I'm biased. They are discriminating against me. If the list has a hidden pattern, the third type is called stratified sampling. What's the stratified? It means divide the school into grade levels and select students from each grade. For example, here we have seniors. We have first freshmen, then what? Sophomore, then junior, and then senior. So I can divide BMU students into 4 categories, okay? And then select students from each category or from each level, okay? Maybe I choose one from each. Advantage: ensures representation across subgroups. So now, instead of randomly going select, and maybe all the 4 choices will be freshmen, because I came in the wrong time. or I came in the ninth and I made the choices for the all seniors. Okay. Disadvantage requires superior knowledge of the subgroup size. So we need to know how big is the group that I'm going to be selecting the students from. Cluster sampling. Cluster sampling, okay, that's the fourth type. Selecting entire classroom from a school for a survey. Advantage, cost effective for large population. That's an advantage. This advantage may not represent the whole population accurately. Now let's take a look at the cluster here in more details, okay? I have it here for you ready, and it's set cluster. Just give me a minute. We'll go to cluster. Here you go. This one is going to be a good example. Like, for example, in the United States, how many states do we have? How many? 50. So we divide we divided the states into 50, right? And then randomly select cluster for sample. Do you see the red states? So out of the 50, I choose maybe 10 states. And then choose all the members from the 10 states. And then take the voting. Just like normal voting. And now, from those 10 states, that will tell me which president will win the race. Because remember, I took random 10 states out of 50. And then I ask everybody in that state to go and do voting. What's it called? Like, it's not a real voting. It's just like primary voting or something before the real one comes out. And this way I can be able to predict who's going to win the race for the presidency. Okay. The third type is convenient sampling. Convenient sampling, if I say, yeah, Hussein, your name is Hussein, right? Yeah, Hussein, can you do sampling right now? Yes, you can. You can write the questions on a piece of paper and give it to the people sitting around you. That's called convenience. You did not go outside, you didn't waste time, you didn't waste money. Just give the survey to the people around you. So that's called convenience sampling. But convenience sampling has an advantage and has disadvantage. The advantage is quick and inexpensive. The disadvantage is highly prone to bias. There is bias because you're only selecting the people around you. Okay? And lack of generalization. What mean generalization? Means you're selecting the people in this area. You're not generalizing for the whole BMU students. For example, you go home, I give you a survey, I ask you to find which supermarket is the best. So you're supposed to go and ask the students or in BMU, come in the morning, come in the afternoon, come in the evening, and then randomly survey the students. But you go home and you survey who? Family. So all the family like Lulu. So that's it. You decided that's Lulu because all the family goes always to Lulu. You cannot lack of generalization, and it's bias. You are selecting one company. Now I'm going to move to another. Of course, there is other sampling techniques. You can go through this by yourself. Let me go back to the summary from the beginning of the lesson. and I will go for sampling and non-sampling error. So sampling error, what does it mean? It means occurred due to sample selection. Okay. For example, using a small sample size that does not represent population. Okay. So just like you did in here, instead of we have like 4,000 students, you only use 10 students to make the sampling from 10 only out of 5,000. Is that enough? That's not enough. Second definition is non-sampling error, result from measurement mistakes or data collection issues. Example, misinterpretation of the survey questions. So you can, whoever is reading your survey, he will misinterpret the questions or the survey. So that's called non-sampling errors, okay? And here's a nice picture. So you can look at the picture and relate this to sampling error and non-sampling error, okay? Now, another type here is called bias types. We have two types called non-response bias, and then we have something called measurement error. What is non-response bias? People who do not respond to survey might differ from those who do. For example, I will survey 50 workers in the company, okay? And out of the 50, how many responses? 10. How many did not respond? 40. Why they put the survey in the trash? Because if they vote or they wrote down answer the survey, they might write really negative comments that might affect the result of the survey totally. So here that's called non-response bias. Another type here is called measurement error. Example, incorrectly calibrate scales in a weight study. For example, you're measuring the weight of the students, right? Okay, and the scale that you are using, it's malfunctioning sometimes. Sometimes it's working fine and sometimes it doesn't work fine. That will result in what? Incorrectly results. And at the end is going to be what? Measurement error. So to get, for example, the average of the weight, and you have a scale that is malfunctioning, means it's giving you wrong results. Then the average, what's happened to the average for the student's weight for the entire class is going to be off. Okay, it's not going to be correct. The second topic here is ethics in statistics. Ensuring informed consent, maintaining confidentiality, and avoid manipulation of the data. Example, hiding unfavorable results in a drug trial is unethical. Do you understand this, what it means? Okay. Ethics is a branch of philosophy that involves systematizing, defending, and recommending concept of the right and the wrong conduct. The term ethics is derived from ancient Greek word is called ethikos, its habit or customs. Okay. Now let's go to the next one here. Ethical standard research must have what? Not use plagiarism. Means you should not be taking someone else's work and put it in your research, right? Not skew their conclusion based on founding. Not commit science fraud. Follow all regulation given. Participate in qualitative study should always be protected. Participants should always be treated with respect. Researchers should do their best to ensure that no physical or psychological harm will come to anyone who participate in the study. Is that clear? Next, use and abuses of statistics. Here we have misleading graphs, cherry picking data, exaggerating results. Okay, number one, suspect sample, confusing average, changing the subject, detached statistics, implied connection that may not exist, misleading graphs, faulty survey questions. Okay. Now, the last summary for this lesson is research methodologies. We have two types of research methodologies. One is called experimental, and one is called what? Observation. So the experiment, testing a new drugs by giving it to one group and a placebo to another. So you're actually testing the drugs, the medication, on two groups. Okay, one group will take the correct drug, and the other one will not take any drugs. It's just like empty pills.
But you will tell them
that they are taking it. Correct. Another types. Remember this in the experiment. You are interfering, right? You are manipulating the drugs. Maybe you can give the group certain size of the pill or weights, okay, or strengths. Now, in the observation, you're just observing. You're not interfering with anything. So, observing the eating habits of population. You'll go to the factory and you see how the people they are in the factory they eat and how they work. Is eating too much in lunch will affect their work performance? So you're not interfering with anything, just watching. Okay. I think we'll stop here and we'll go take a break to go to pray, and then we'll come back. Okay.